Now let us learn how to do simulation of this multivariate time series or vector autoregressive process. So we have this equation. So this I have copied just from the last lecture. So you have this equation. So I said in the last lecture that we need 3 input to it. So first is we need, say, the constant matrix of 4 7. So this is the constant matrix of 4 7. Then we need a coefficient matrix. So the coefficient matrix we computed last time was 1 minus 0.4 plus 0.4. That you can see from here. You have the identity matrix 1 0 0 1. Then you have 1 coming from right here. Then this 0.4 goes on the left hand side, becomes minus 0.4, and this minus 0.4 goes on the left hand side and becomes plus 0.4. So first we are just considering lag 1 variables. Okay, then 0, and again we are considering only variables which have x in it. So we are going to consider these two, take them on the left hand side, 0 0. So you will have plus 0.2 plus 0.2. So the first column is all about x variables, the second column is all about y variables. You start from here 0, then this variable is yt minus 1, so minus 0.1 goes on the left hand side, becomes plus 0.1. This is yt minus 2, goes on the left hand side, becomes minus 0.6. You have 1 here, you copy 1 here. This yt minus 1 goes on the left hand side, becomes minus 0.6. This goes on the left hand side, becomes minus 0.2. And that is it. So this is our matrix, and that's precisely what we feed in the coefficient matrix here. So it is 1 minus 0.4 0.4. So 1 minus 0.4 0.4. Then you have 0.2 0.2 0.2 0.2. You copy this, so you are done with x. Now you come to the second variable, that is 0.1 minus 0.6. So 0.1 minus 0.6, and then you have variable 1 minus 0.6 minus 0.2, 1 minus 0.6 minus 0.2. So this was our coefficient matrix. Then you have the constant matrix 4 7, which I already talked about. Then you have this correlated white noise, which has to be drawn from a matrix with mean 0 and variance covariance is sigma. So sigma here we are feeding in is 0.9 0.7 0.7 0.8. So this is number of rows is 2, number of columns is 2, so you can say it is 0.9 0.7 0.7 0.8. So this is our variance covariance matrix which I am feeding in it. So this is all you have fed in. This is your model. So the model fitting is done by the command ARMA. As I said before, you have 3 input. First is the coefficient matrix right here, then is B equals to D. This D is this matrix of our variance covariance. So B is our sigma matrix, this one, and trend is these two constants 4 and 7. So this is the trend. So this is the model. This is the model. So let us run up till here and see whether we have fed inside the correct variables. So the code is given in the description of the video. Notice that you have to install the DSC1 and DSC packages as well as package var. Otherwise you won't be able to get these libraries DSC1 and library vars. So the total number of variables we have is 2. You could have as many variables as you want to, and the number of simulations which we are going to do is 500. So let us first run these commands and see what our coefficient matrix looks like. So the coefficient matrix, the first variable and the second variable. So this first variable just shows the variable xt we have. So you have xt, then you have one lag, then you have the second lag, then you have xt again. So this is one lag, this is second lag, and similarly for the second variable y of t. So this was the coefficient matrix we fed in, but this is how it comes out if I run this command. This is because the way we are giving it as 3 2 2. That is, you have 3 rows and 2 columns and 2 matrices. Now this is the command which goes in the package. You cannot do anything about it. You have to feed in this way. So this is a constant matrix 4 7, and this is the covariance matrix is matrix G. So let us run these 3 set of commands. So this was the covariance matrix which we have fed in. You can choose your own covariance matrix, and this is our model. So let us see what our model comes like. I'm going to run it. So this is the model. The trend was 4 7, the 2 constants. This was it. 1 minus 0.4 was a lag 1 plus 0.42 was lag 2. So this is again lag 1 lag 2. This was again, this is precisely the matrix, the coefficient matrix we started with the matrix A. This is our variance covariance matrix, from where we will draw our innovations, noise, or error term, whatever you want to call it. So this is white noise. So random walk and white noise are separate. Sometimes I'm saying something, I tend to mix them up, but white noise is just drawing from the normal matrix or the normal variable, whereas random walk is a cumulative sum. So now we have this var sim is about simulate. So what do you simulate? You simulate this model 2, which we have just written. So this model has a trend, this has the lagged variables, and this has the variance covariance matrix. So you got to simulate this model. The sample size, number of simulations is 500. So 500 simulations we will get. So the noise, so we are going to draw variables from the random normal matrix. We are going to draw 1000 variables, because first 500 we need, so this number of simulations times number of variables. So for every variable we will require 500 normal random variables. So we will come back to this command in a minute. We'll talk about it. So what it is doing essentially is it's going to draw from a matrix of normal random variables, but it is going to feed it into this model 2. So this model 2 will feed, will have an input of random normal variables, which will go into the this variance covariance matrix to get correlated random walk. And then you can, once you simulate it, you get the results. So let us do the simulation. Let us do these two. So you see, you simulate it, you get 500 values, and let me go at the top of it. So the output data, this is first simulation result, and then so we are just simulating it 500 times. So every time you simulate, you draw a new value. So you can see every simulation has different values. So this is not going into the future. I'm not predicting 500 days ahead. So keep that in mind. I'm not predicting anything. It is just I'm drawing from the sample again and again. So there is nothing special about 1 and 2. 1 and 2 are just two different simulations. And this varmat just puts this simulation in a matrix form so that it is easy to draw variables later on. So that's pretty much it. I'm just going to take the var sim output and put it in a matrix form. So just let us run this. So that is it. I have just taken the previous variables and put it in a matrix form. So nothing much has been done. So let us go back to the code and just understand the var sim command again. So we are back in the var sim command right here. So this is the simulation command. You simulate model 2. To simulate model 2, you have to feed in random normal variables. These random normal variables will automatically feed into the coefficient matrix, which is right here, or right here. It is also in the model 2, and that will give you this correlated noise. So you can instead of noise in the code I have given, you have written noise in the description of the video. Instead of noise, you can also put innovations. So basically this this innovations is nothing but, this is a matrix which has number of rows as 500 and number of columns as 2, because the number of variables are 2 and number of rows are 500. So this is basically trying to do 500 simulations, and then when you get var sim, you have 500 simulations. So the first column is our variable x, the second column is variable y, and you are just drawing 500 times. So notice that this is not prediction, this is just simulation. So there's nothing special about 1, 2 or 3. You are just simulating 500 times. So your future price could be any of these 500 values. And then I just put it in a matrix format because this we will use in the later lectures. So this is how you do the simulation. The code is given in the description of the video, so you can copy paste it.